Awesome.
All right, can you guys see it?
Yes, Alejandro.
Okay.
Go ahead.
So this is our project. So who said it? You said.
Our product is called Clairvoyant. For our project, we decided we want to do something related to the medical field. We utilize YOLO V5 object detection system to read X-rays as well as head CT scans, specifically to differentiate between healthy, hemorrhaged, and tumorous brains, as well as to be able to identify scoliosis through a spinal X-ray. The system was trained based on images of head CT scans of multiple patients who have either tumors or hemorrhaged brains, as well as spinal X-rays from patients who have scoliosis. The dataset for head CT scans was taken from Kaggle, and we also utilized SERP API to web scrape for our spinal X-ray images. In the future, we hope that this project can be applicable to assist doctors in detecting abnormalities with higher confidence. We also know that it is unrealistic to expect our project to work with 100% accuracy. Because of this, our minimum viable product, or MVP, for this project was to be able to differentiate between an unhealthy and healthy brain by clumping hemorrhage and tumorous into a single class. However, the optimal product, which we were able to achieve in the end, was to identify healthy, tumorous, and hemorrhage brains individually.
So as you may have not heard already, but our AI name is Clairvoyant, meaning having the power to see objects or events that can sense that the sense cannot perceive. So we picked this name because we felt the name described what our AI primarily does, with our AI detecting hemorrhages and often doctors having a very difficult time doing that themselves. So if you scroll down a bit, you'll see all the tools that we used. We used Python and Flask to write the backend code, YOLO as the primary machine learning model, HTML to make our website, and RoboFlow and Kaggle to gather our data sets. So do you guys all mind introducing yourselves?
Yeah, I can go first. Yep, so my name is Daniel. I'm actually going into my second year of university. And yeah, I enjoy making art, exercising, and that's me.
Yeah, I'm Andre. I'm a rising senior at Brooklyn Technical High School. I did several programs this summer, including AI Camp, and I'm really excited to be able to apply this knowledge in the future.
Hi, my name's Sriram. I'm an 11th grader, and I enjoy coding, and I hope to pursue something in the software field in the future.
Hi, I'm Supraj. I'm a rising senior at John F. Kennedy Memorial High School. And through AI Summer Camp, I hope to see the applications of computer science to other fields.
Hi, I'm Brayden. I'm currently a sophomore at the Morris County School of Technology. I enjoy playing basketball and video games with my friends and watching movies with my family. And when I grow up, I hope to pursue a profession in cybersecurity.
Hi, I'm Alejandro. I'm going into my junior year of high school, and I enjoy coding very much. Very excited about what we've made here. So now let's go to the actual demo of projects, and then we'll explain how it works behind it. So here you have an option to input your own file, and if you're not one of those people that has a random X-ray image or CT scan lying around, you can choose one of the images provided here to actually download and input into the file. And then over here is the detection. And then my partner, Supraj, will explain the confusion matrix. So first, to show you, I have one lying around here. So you do that, and then you just submit it, and it shows you up here the confidence of the label right here, and then the confidence, and it shows you the image. If you want to download one of ours, you download it, shows up right there. And then it shows up right there, and you just open it, submit it, and you get that the confidence of the scoliosis in this image is 25%. So we just used, to make the overall layout, we use HTML and CSS, and we use some JavaScript and CSS to make these cool effects and buttons. And yeah, let's get into the confusion matrix.
So there's a lot of different ways you could evaluate a project like this. And one of them is precision. And it's good for usually less serious projects. And it's useful for when you want to minimize false positives. Another way you could do it is through recall. And that's useful for when you want to minimize false negatives. And that's good for more serious projects. Since we're doing a medical project that's more serious, we wanted to choose focusing on recall over precision. On top of that, we also wanted to evaluate based on the confusion matrix. And as you can see, there's a 77% accuracy for hemorrhages, 86% for scoliosis, and around 50% for tumors. Since brain tumors and hemorrhages look somewhat similar, it makes those have like those are less accurate than the scoliosis. And brain tumors probably had less prominent features for the network to analyze, since hemorrhages got confused with the background less often. And then scoliosis did pretty well because it probably had the most prominent features out of all of them.
Yeah, and also we ran into the issue that we were overfitting a bit with tumors. So one of our classes was actually underrepresented in our data set. So we had to deal with that. And now setbacks.
Right. So as was mentioned previously, the way we trained our model was by feeding YOLO a bunch of images of scoliosis, tumors, and hemorrhages, right? And iteratively training it. And we met a lot of setbacks. Initially, if you can scroll down, Alejandro, our matrix, our confusion matrix looked a lot worse. We had a lot lower values for all of our predictions. It was pretty bad. Like, it would sense it, but the confidence was really low, too low for a confident analysis of CT scans, right? So one of the problems was that our AI struggled differentiating between tumors and hemorrhages, right? They do look pretty similar. However, there are small differences that even the human eye can see, right? Like tumors have small dark spots inside, or sometimes it's light spots, but there are differences that our AI couldn't perceive. And we had to solve that by giving it even more data, by web scraping more data from the web instead of actual data sets, and adding it to our model and training it more and more until the AI could finally tell the difference. And what else was there? Right. And as I said before, our AI detected with low confidence. And again, that issue was also overcome by just finding more data. I think in the end, it was around 1,500 images that we found with augmentation, meaning that we modified them slightly in some ways to to train the model better. So the way that works is that we find maybe 500 images of things we actually want, right? So a total of 500 images for hemorrhages, scoliosis, and tumors, and then we modify them, apply effects like blur, skew them a bit to, in a way, confuse the eye, but also train it harder so it can detect maybe images that are lower quality or have a slight shift.
Yeah, so I will explain our future sites, but all in all, our medical anomaly detector, it does an all right job at detecting brain tumors, hemorrhages, and scoliosis. But of course, you can see that we need to do more work to make it more accurate. But when we do make it more accurate at making these predictions, there are some useful implications of our model, such as how it can augment medical technologies that require the automatic detection of these tumors and stuff. For example, maybe we can have a machine that needs to take some measurements, and then if it can like automatically detect the like a brain tumor, that would be very useful. Then also in the future, we can also like expand and improve our project by training it to detect more specific details, such as like the type of tumor or the grade or degree of it, or maybe even like the risk of operation. And so I think that's that. I hope you guys can see like the important potential of our project, our product, and yeah,